Let's take a look at your dev environment. This is your local machine. You have your OS, your Node.js installation, your packages, and finally your code. You can share your packages and code with your friend who has a different machine and a different setup. The same packages and code might have incompatibilities within his setup, which causes the works in my machine problem. Let me offer a different approach. Instead of writing code directly in your local machine, create a container for each project. The container is almost like a virtual machine with its own file system, Bash, and other softwares like Python or Node.js. You can spin one up, jump into it, and install everything needed for your code to run, and finally run your code exactly as you would in your local machine. Whatever else you have installed in your machine does not matter. The container is an isolated environment. This container can also be reliably reconstructed on any machine. Your friend could recreate the same container on his machine or on a production server with complete trust that everything would work exactly as it did on your machine. So what does this look like in practice? Let's say you're creating a new Node.js project. So you create a directory for this, and before you write any code, create a Docker container. In order to do that, you need a Dockerfile. The Dockerfile contains all the instructions Docker will need to spin up your container the exact same way every single time. You start with the from command. You can start with a base image like Ubuntu, but it's much easier to start with something that has a specific version of Node.js already installed. The second command is work directory. It's similar to the cd command, which sets the working directory for your project. If your code is going to run a server at a specific port, we need to expose that port from inside the container. We do that using the expose command. Next, we need a compose.yml file. Start by giving our service a name. The build property specifies the directory where we have our Docker file. The command property is the final command that will be run inside our container once it has been created. For development purposes, we're going to run a bash shell. The volumes property can be used to mount a directory from our host machine, which in our case is our local machine, to a directory within the container. We use this to sync the code files present on our host machine to those present inside the container. This means we can edit our code with our favorite editor within our own machine and have those changes reflect inside the container. tty and stdin_open are required to keep the shell running even when we are not inside the container. The ports property is used to map a specific port within the container to a port inside the host machine. For example, our server will be running at port 3000 within the container, and we can map it to port 3001 on our host machine like this. Next, we will run docker compose up -d to create and run our container without jumping into it. We can see the list of running containers by docker ps command. Now we can jump within this container by running docker exec. We can copy the name of the container from here. Now we are in a shell within our container. We can run all sorts of commands. For example, npm init. We can install any packages needed like this. We can add some code from within our host machine using any editor we like. I'm adding a simple express server for demonstration and save this. We can also make changes to package.json file like this. The code changes will be visible within the container as well. Now we can run the code like this. As you can see, our server is running within the container. We can access this server at port 3001 just as we had configured. Simply write exit to get out of the container. Now that we have package.json and package lock.json files, we can change our Dockerfile like this. After setting the working directory, we can add the copy command to copy both of these files to the working directory within the container. After that, we can use the run command to run npm install so that the appropriate packages are installed within the container. This is good for development, but what about production? For that, we'll create a different compose file. We will copy everything from our original compose file and change a couple of things. We don't need the shell command over here because we won't be jumping within the container for development purposes. Instead, we can add node app.js command to start our server once the container is ready. We also don't need tty and stdin_open properties. Instead, we can add a different property called restart and set its value to always. This ensures that Docker restarts your server if it crashes for any reason. Now we can clone all of this within our production server and run docker compose -f with the new compose file like this, and it will start our server. We can still access this at the same port as before. To check the list of running containers, run docker ps, and to stop a running container, run docker stop followed by the ID from over here. It's also a good idea to remove any containers which are not running anymore by running docker rm followed by the container ID. Your code can be conveniently used by anyone on any machine once you are done with this. All they need to do is clone your repo and run the appropriate docker compose command. They don't even need NodeJS installed on their machine, as everything will be installed within the container.